Right, welcome everybody. Today we're finishing up with the applications of the law of sines and cosines. So just a quick reminder of these two laws of sines and cosines. Here we have the law of sines. Again, you can kind of choose which one you want to use. Really, the top works really well if we're trying to solve for the sides. Because like if we're solving for a, then all we need to do is multiply both sides by like the sine of a, the capital A, right? The angle A. If we're trying to find the angle A, then it's more helpful to have it on top. So then it's just a two-step equation. We just times both sides by the side A, and then we'd use like the sine inverse to get angle A by itself. So, but again, they're the same equation, just really depends on what we're solving for, okay? The law of sines, again, there are conditions. You can't just use any combination of sides or angles. We really need to find a side that we know the angle that's across from it. If you know that, then we can use that to solve one of the sides. But in generic terms, we'd maybe want to look for anything that has an angle side, or an angle side angle, or if you have side angle, okay? But again, I think it's just easier to visually see if we can use it or not. Next off, we have the law of cosines. Again, this works really well if you have side or side angle side. Again, these two equations are the same, just one is solved for the side C. So if you're trying to find side C, then we're good. If we want to find angle C, then we'd maybe want to use this equation, okay? Just a reminder that when we're using angle C, we have to use the side that's opposite, okay? And then A and B, those are just the sides that are next to or adjacent to that angle C, okay? So A and B are the sides that make C be included, right? So it's inside those two sides. Same sort of thing when we're going in to find like angle C. A and B, those don't really matter as long as they're the sides that are next to that angle C. So these could be swapped. It's just fine. But C, the side that's opposite of that angle C, that has to be the one that we subtract, okay? So we're going to do a couple of those, just doing word problem form. You'll see a couple of these on your test, so it's probably good that we go and talk about it here, okay? So the first part is not to actually solve, it's to decide which law we would use, law of sines or the law of cosines, and why. So if we look at this first example, again, we have side angle side. And again, that's one of the things that we'd want to look for when we're doing cosine. So law of cosine is the way we'd want to go. Next one we have angle side. So that's one of the ones that we talked about that we use with the law of sines. If we want to think of it the other way, we'd want to know, well, I guess this one's a pretty straightforward one. We do have a side that's opposite of an angle, and then we have one other angular side, so we should be good for the law of sines. Okay? All right, so we're just going to go and do a few examples. Hopefully this doesn't take too long. I don't know that I'll go over every single problem. There's like 5 examples. The ones I think for sure that you should be aware of, so if you ever stop the video, I would make sure that you for sure talk about this airplane one. I guess we have 2 airplane ones. I think this is one that you'll probably see similar to that on like your homework, and I think this is another airplane one that might be good to have a look at. So for sure, maybe go over those. I'll probably go over those three, and I'll probably also talk about example 1. Okay. All right, so a professor from UNC drives 9.8 miles to get to a symposium at Duke in the morning. Okay, so just to keep this a little simplified, I'm going to redraw this triangle, and this is UNC, this is Duke, and then over here would be NC State. And it tells us that it's 9.8 miles to get to Duke. He then turns 23.9 miles, so this angle here is 23.9 degrees, and then he drives to NC State in Raleigh. Okay. The two roads, oh wait, sorry, I put that in the wrong spot. Sorry, it's 23.9 miles, okay, and the angle, the two roads make a 100-degree angle. Okay, hopefully I didn't mess that up too much. Okay, use the law of sines or cosines to determine how far he will have to drive to get from NC State back to UNC. Okay, so basically it's asking us to find, why don't we call this little d, since it's across from Duke. All right, so to figure this out, again, we're going to need, this would be kind of like the first example that we had. So we'd do d squared, and again, we want to use the sides that are next to that 100 degrees. So we do 9.8 squared plus 23.9 squared, and then we subtract 2 times those same two sides, so 9.8 times 23.9, and then we do cosine of our angle. Okay, and then again, if we want to just get d by itself, we need to square root everything, and we'd put that into our calculator. Okay, so if you put that all in, we should end up getting d equals 27.36 miles. Okay, hopefully that's okay. It says now find the angles made at the University of North Carolina and North Carolina State, so NC State. So I think they just want us to find this angle, and maybe I'll use a different color over here. We'll do purple, this angle here. Okay, so let's start with that green angle. Maybe we'll call it angle U, because it stands for UNC. So again, if we're trying to find an angle, we're going to use the other kind of form that we would use over here, right? So the bottom one, if we're trying to find the angle. Okay, so we would have, cosine of that angle is equal to, and again, we want the sides that are included or touching that angle. So just to make it a little, I'm going to put this right over here that we came up with. Okay, so these are the two sides that are attached to or next to that angle that we're trying to solve for. So we'll do 9.8 squared plus 27.36 squared, and then we want to subtract what's across from it, so 23.9 squared, all over 2 times those sides that are touching angle U. So 9.8 times 27.36. Okay, so then we would put that into our calculator. Well, I guess maybe before that, we'd maybe do cosine inverse on both sides. Sorry, I kind of forgot that part. And then we'd put that into our calculator. Again, if you have questions putting that in, let me know. And we end up getting U equals 59.35 degrees. Okay. And then we also want to find the angle for NC State. So again, if we're doing that, we could maybe call that angle N. I don't know, call it N. Call this one U. Okay, so if we want to find angle N, we know two of the three angles, so we could do 180, subtract 100, and then subtract 59.35. And we would end up getting 20.65 degrees. Okay, so that gives us those two other angles. And then the last thing that's kind of finishes everything that we've maybe talked about, well, I guess maybe not the law of sines. It says, what is the area of the triangle region? Okay, in square miles. So again, the equation for an area of any type of triangle is 1/2, and then we do the two included sides. So we could call it B and C or anything, right? And then we'd do sine of that angle that's between the other two sides. So for this one, again, we're not maybe using those letters, but we could do maybe the angle that they give us. It's always good to choose, sorry, I don't know why I put 100 there. Maybe use the angle that we know, just so that we don't have any rounding error. So if we do that, then we would use the two sides that they have already given us. So it would be 1/2 times 9.8 times 23.9, and then we times it by sine of angle A, which is 100. Or I guess that's our angle D for Duke. Okay, we put that all into our calculator, and we should end up getting 115.33 miles squared. All right, so there's one example. We'll maybe skip example 2. I think example 2, you could do right triangle trig. You could do, I think, law of sines here as well. But I think you're going to find more success if we make sure we go over these next 3 examples. So it says a lighthouse on a beach is 110 kilometers from a boat and 95 kilometers from another boat. Okay, so I'm going to draw myself a little, this is my little lighthouse. Okay, have you ever climbed a lighthouse? Sorry, that was not super great at the top. Okay, so we can see 2 boats. We see a boat that's 110 kilometers to one boat. Here's my boat. And then they also tell us that 95 kilometers we see another boat. And they want us to know, or they also tell us the included angle of the sight lines from the lighthouse of the 2 boats is 52 degrees. So this would be 52 degrees. And they want us to find the distance between the 2 boats. Okay, so again, we could label the sides. If you think that's helpful, we could call this A, B, and C. Across from that angle would be little c. That's what we're trying to find, is that side length. Okay, and we want to set up the equation. So this for sure is a cosine, right? Law of cosines, because we have side angle side. So we'll do c squared equals the 2 sides that are next to that angle, the included angle. So we'll do 95 squared plus 110 squared, subtract 2 times 95 times 110, and then, let me try that one more time, 110, and then cosine of 52. Again, we'd maybe square root both sides, and we would get C all by itself, 90.87 kilometers. Okay, and I'd encourage you maybe to type that in and make sure that you can do that okay on using your calculator. Okay, if you have any questions on that, please stop by. All right, so next off we have a pilot that flies from Salt Lake International Airport going directly west for 2 hours. So like say this is Salt Lake City and it says it drives for 2 hours, but because of a thunderstorm, the pilot is asked to make a correction course 20 degrees to the right of its original course. So it's gone straight, but at this point, normally we would continue going, but it's asked us to divert our direction 20 degrees. Okay? And so the airplane is somewhere over here. That's my nice airplane. All right. And then it says, if the plane was averaging a speed of 55 miles per hour, how far is the plane from the airport, the Salt Lake Airport? Okay. So, oh, and it said it goes another hour. I kind of missed that part. So we got an hour here. Here we've got 2 hours. Okay. And they want us to know how far is he from the original airport that it took from. Okay, so again, this one's a little tricky just because the 20 degrees isn't part of our triangle that we're working with. So to figure out what this is, we'd do 180 subtract 20 and we'd get 160 degrees. They tell us that they fly for 2 hours going 55 or 550 miles per hour. So how far did it actually go for the first 2 hours? 2 times, we'll put it here, 2 times 550. So that will give us 1,100 miles is that length. And then it turned 20 degrees and it went for another hour. So this would be 550 miles. Okay, that's probably in the middle of the ocean right now, though. I don't know how accurate this is at the direction going from Salt Lake City, but that's not really the main idea here. Okay, anyways, sorry. So we're trying to find the angle that's across from that 160. Maybe we'll call this angle C, and this would be little c, okay? And we need to find that length. So we'll do c squared equals 550 squared plus 1,100 squared, subtract 2 times those same 2 sides, so 550 times 1,100, cosine of 160 degrees. Again, we'll square root both sides and put that into our calculator. Again, maybe pause if you need to, see what you end up getting. Okay, but I end up getting 1,627.74 miles. Okay. All right, so it's a little bit longer than it would have been originally. Originally, if we added those together, like the distance that they traveled would be 1,650. But again, it's always shorter if you go straight from directly between 2 points. So it's a little shorter. It is from the Salt Lake Airport. Okay. All right, last one. It says 2 airplanes leave JFK. I'm actually going to go there soon. But anyways, JFK Airport at the same time. So here we have like our tower. Here's my little tower. And our airplane goes in 2 different directions. We have one going that way maybe and one that's going this way. Okay. It says the first airplane travels 360 miles per hour, and the second plane travels 650 miles per hour. After 2 hours, they are 1,600 feet apart. Okay, so we know that this length here is 1,600 miles apart. we need to know the lengths of the other two. They tell us the miles per hour, and they tell us that they go for 2 hours. So here we just need to do 2 times 380, and that will give us 2 times 380 would be 760 miles. And if we do the kind of the same thing here, 2 times 450, this would give us 900 miles. So we have all 3 sides. So this would be side, side, side. Sorry, I think all of these probably need to, maybe we should go over example 1. I think all the other ones all used the law of cosines. Okay, so maybe we'll go over that. So here we do law of cosines. Again, we're solving for the angle made by those 2 airplane paths. Okay, so we could call this big C. This would be little c. So when we set this up, we'll have cosine of big C is equal to, again, our adjacent sides. We would have 760 squared plus 900 squared, subtract 1600 squared, all over 2 times those same 2 adjacent sides. So 760 and 900. And then if we want to get angle C, we'd need to do cosine inverse on both sides. So if we take that and we put that into our calculator, I think we end up getting 161.86 degrees. Okay, so maybe my drawing needs to be more like this, something a little further away, but I think that's pretty good. All right, so maybe we'll go over and do a law of sines here. It says safety regulation states that the max angle of elevation of a ladder is 62 degrees. So we have some sort of angle here. We'll maybe draw some sort of triangle. Okay, and it tells us that this is maybe our ladder. Sorry, drawing a ladder. And it tells us this angle should be 72 degrees. A fire department's longest ladder is 110 feet. What is the max safety rescue height? So they want to know what this is. We can assume that this would be a right triangle because height is always vertical. Okay, so here we could just use SOHCAHTOA, but we might as well do an example where we do the law of sines. So this is 90, and we want to first maybe find the side that we're trying to solve for. So we'd have h over our angle, so sine of 72 is equal to, and then we do the same ratio. We do the side on top over the angle. And then we would multiply both sides by sine of 72. And we would put this into the calculator. So if we do that, we should end up getting x equals, 104.62 feet. So that's how high safely this fireman could reach with that ladder. Okay? All right. Well, if you have any other questions, please let me know, and we will see you later.